Hi grade 10s, welcome to the first session for the winter school. If you click on the grade 10 page, you will see I've created a separate tab for the winter school. So click on that and it will open to what is there so far. So as you can see, the theme for the winter school is chemistry and its important role in technology and culture. And the first session looking today is to revise what you understand by, let's just have a look at that. It's to revise what you know about chemical change. Let me just move that so you can all see it. Okay, is to revise what you know about chemical change. There's a discussion forum for you to answer the questions. And then we're going to look at the conservation of mass. Understanding the conservation of mass is the first important step to understanding why chemical reactions can be quantified. In other words, why we can measure out certain amounts of reactants to get certain amounts of products. That you will cover in more detail when you do stoichiometry. So this is just to ensure that the foundation is built for you. So I hope you enjoy this session and the next 3 sessions to come that will look at ways of representing and quantifying chemical change. Chemical change and chemical reactions have played an integral role in every society from the dawn of time. People might not have understood chemical change, but these chemical reactions have formed an important part of both the technology and culture in the development of societies. Today we're going to look at beer brewing and iron smelting, both traditions that have a long history in Africa. So beer brewing, African tribes have been brewing beer longer than is recorded in history books. Sorghum is a malt and grain that has the main ingredient, that has been the main ingredient for centuries. Now, traditionally, it's prepared with equal parts crushed maize, malt, sorghum, and water is added. The mixture is left overnight to begin the fermenting process, and bubbles are produced, as well as that characteristic sour odor. The mixture is then cooked and poured into larger containers for further fermentation. And so this has been, the brew is ready for drinking. To make sure it's ready, a match is lit. And if it goes out, then it is ready to drink. The other process is iron smelting, which also has a long tradition in Africa. And it dates to about 3000 BCE. With the Bantu expansion west, the technology also spread east and then down to southern Africa. So the use of iron allowed an expansion in agriculture, industry, trade, and political power. The Bloomberry Furnace was used. It consists of a pit and it has heat-resistant walls. The first step is you make your charcoal, which is nearly pure carbon, and it produces a high temperature that is needed for smelting. The ore is broken down to remove moisture, and inside the furnace, carbon monoxide is formed, and this is used to reduce the iron. So thinking back to what we've done, can you remember the clues suggesting a chemical change has taken place? Because remember, a chemical change occurs whenever matter changes into something entirely different with different properties. That is called a chemical reaction. So what are those clues? Are bubbles produced? Okay. Is there a color change? Is there a change in odor? Is there heat, light, or loud sounds produced? Your first task for today's session is to identify whether the process of beer making and iron smelting are chemical changes. So, just in terms of the discussion board, if you click on today's session, you will see there has a chemical change occurred. When you answer the questions, you can answer them there, and the tutors will be there to look at your answers and see if what you have said is correct. So I hope you enjoy the session. So grade 10s, we're going to look at a practical demonstration to show that mass is conserved during a chemical reaction, and I've asked Mr. Tate if he will show us this demonstration. Now it's very important to note the way that the experiment is set up to ensure that there's no spillage, but you can see that the mass, as you will see, the mass before the reaction must equal the mass after the reaction. And then we're going to look at the particle level so that you can then use this principle to see that mass is conserved before and after a reaction.
Hi guys, Mr. Kane here for a quick chemistry demonstration. This is going to be law of conservation of mass, or law of conservation of matter, depending on which way you like to talk about it. So the law basically says that in any chemical reaction, matter or mass is conserved. It cannot be created or destroyed. That means that when you start a chemical reaction, the mass before and the mass after should be the same. I've got some calcium chloride here, which I'm going to use to place in the Erlenmeyer flask. Exact amounts are not necessary in this demonstration, so that's probably about enough. Place that on my balance here. In order to have a chemical reaction, we need two chemicals, so I am also going to add some sodium sulfate. I'm going to add it in this test tube. About half full should be good enough. Okay. So I'm going to place the test tube inside the Erlenmeyer flask. Notice that the two chemicals are not mixing yet. I'm also going to use a stopper to stop up the top of the Erlenmeyer. And we are now going to note the current mass on the balance. You should be able to read that. It says 369.1 grams. 369.1. Now, in order to get this reaction to occur, I've placed the stopper on the flask. That way, if there's any gases created, it won't allow them to get out. Also, in order to get this, in order to get these two solutions to actually mix, I have to flip it upside down. So I'm going to flip it upside down, carefully agitate so that the two solutions actually mix. And you can see there's a pretty startling reaction here. When I place this back on the balance, what you're going to notice is that it's the same mass as before, plus or minus a decimal place. 369.2. Okay. Now, the way that I know a chemical reaction happened here is because of two things. Number one, I have a color change. It went from a clear solution to a white solution. The other thing that that's telling me, it's cloudy. So I now have a precipitate that has formed.
Okay, so let's see how we can use conservation of mass to see what the mass is before the reaction and the mass after the reaction. So here is the carbon burning with oxygen. Carbon, if you go to the periodic table, has an atomic mass of 12. Okay, so if we had, we could have 12 grams of carbon. Oxygen is a molecule that consists of two oxygen atoms, and those oxygen atoms are 16 grams and 16 grams, so that's 32. So 32 plus 12 is 44 grams. Now, let's have a look here at the carbon dioxide. One carbon, so that's 12, plus 16 is okay. Now, grade 10s, you will find this worksheet in today's session. What you're going to do is look at each of the reactions, firstly in iron smelting, and you're going to go to the periodic table and find the relative atomic mass units. But before you do that, you have to write out the number of iron atoms as reactants, the number of iron atoms as products. You do the same for glucose. So it's basically adding up all the atoms, seeing how many are on the reactant side, the product side, going to the periodic table, finding their masses, and showing that the mass before must equal to the mass afterwards. So if you have any queries, you can ask your questions in the discussion box. So good luck.